So here we have three sets A, B and C, and we need to verify the following. Okay, let us begin. So first we will start with the Cartesian product of A and B union C, and we have to show that that's equals to the union between the Cartesian product of A and B and A and C. Okay, that means we will try to find out each of them individually. So we'll start from the left hand side. So on the left hand side, this is the first part of the problem. So we have the Cartesian product of A with B union C. Okay, so the set A contains three elements, 1, 2 and 3. So we're going to take its Cartesian product with the set B union C. So let's try to find out the set B union C. The B union C, we have the set B containing the element 4 union with the set C containing the element 5. Fine. So that means when we take its union, there are going to be two elements, 4 and 5. So we have B union C, that's a set containing two elements, 4 and 5. Now we can take the Cartesian product. So we'll start with the first element of the set A, which is 1, and form an ordered pair with each of the two elements of B union C. So we are going to get two ordered pairs. One will be 1, 4, and the other is going to be 1, 5. Next, we will take the second element of the first set A and form an ordered pair with each of the two elements of B union C. So we will be getting 2, 4 and 2, 5. Next, we will consider the third element of the first set, which is 3, and then we will form an ordered pair with the two elements 4 and 5 to get 3, 4 and 3, 5. Okay, so this is the left hand side. So we are getting an ordered pair 1, 2, 3, 4, 5, 6. There are 6 ordered pairs. Let's see that this is also equals to the right hand side. So on the right hand side, we need the Cartesian product of A and B. We'll have to obtain that separately, and we'll have to find its union with the Cartesian product of A and C. Now let's try to find out the Cartesian product of A and B. Now A contains three elements. So we have the set containing three elements, 1, 2 and 3. We're going to find out its Cartesian product with the set B containing a single element, which is 4. So there will be three ordered pairs. So we have 1, 4, 2, 4 and 3, 4. The procedure remains the same. It's very important to follow the order. Let's try to find out the Cartesian product of A and C. Now A again has got three elements, 1, 2 and 3. We're going to find out its Cartesian product with this set C, which contains the element 5. This is also going to give us three elements. We have 1, 5. We have 2, 5, and then we have 3, 5. Okay, now let's try to use this value. So the Cartesian product of A and B, that gave us three ordered pairs. We have the first ordered pair 1, 4, followed by 2, 4, and then we have 3, 4. We're going to find out its union with the Cartesian product of A and C. So that's going to be 1, 5. Next we have 2, 5, and then we have 3, 5. Okay, fine. Now since we have to take in union, so what we'll do, we're going to take the common elements. So we have 1, 4, 2, 4, 3, 4, and next we have 1, 5, 2, 5, and 3, 5. Now when we compare the left hand side and right hand side, we immediately observe that the left hand side equals the right hand side. So this proves the problem. That means if we take the Cartesian product of A with B union C, this is going to be equals to the Cartesian product of A and B union with the Cartesian product of A and C. Okay, now let's go to the second part. So this time we need to take the Cartesian product of A with B intersection C, and we'll have to show that it equals the Cartesian product of A and B intersection with the Cartesian product of A and C. Okay. So let's start from the left hand side. So on the left hand side, we have the Cartesian product of the set A with B intersection C. And that means we have the set A containing the elements 1, 2, 3. We're going to find out its Cartesian product with B intersection C. Let's try to find out B intersection C. Now B intersection C simply means we have the set B containing the element 4, finding its intersection with the set C, which contains the element 5. Since both of them do not have any common element, this is going to give us the null set. So that means we're taking the Cartesian product of the set A with a null set. And we know whenever we're taking Cartesian product of any set with a null set, that's always going to give us a null set. Okay, coming to the right hand side. So on the right hand side, we have the Cartesian product of A and B intersection with the Cartesian product of A and C. Now we have already obtained the Cartesian product of A and B in the previous problem. We're straight away going to use these values. So here we see that if we consider the ordered pair of Cartesian product of A and B, which is 1, 4, that is not present in the second Cartesian product A and C. Similarly, if we pick any elements, none of them are going to present. This simply means that there are no common elements. Since we are going to find out an intersection, there are no common ordered pairs that exist between the Cartesian product of the sets A and B as well as A and C. So this is also going to give us a null set. So this simply tells us that the Cartesian product of A with B intersection C, this is going to be equals to the Cartesian product of A with the set C intersection with the Cartesian product of the set A with set C, and both of them are going to give us a null set if we use the value of A, B and C as given in the problem. Now let's go to the third part of the problem. Let us start from the left hand side. Now on the left hand side, we have the set A, its Cartesian product with B minus C. Okay, we'll need to find out B minus C. So what is the set B minus C? B minus C simply means let's take the element of set B, which is 4, and from here subtract the elements of the set C, that is 5. So B minus C means we only have to pick up those elements from the set B that are not present in the set C. Now since B contains only 4 and then that 4 is not present in the set C, this is simply going to be the set containing a single element, which will be 4. So we are going to find out the Cartesian product of the set A containing the elements 1, 2 and 3 with the set B minus C, which contains the element 4. Fine. So this ordered pair, we'll get 3 ordered pairs. One will be 1, 4. Next will be 2, 4, and then we have 3, 4. Fine. Next, we come to the right hand side. On the right hand side, we have the Cartesian product of the set A and B minus the Cartesian product of A and C. Fine. Now, Cartesian product of A and B minus A and C simply means that we only have to consider the ordered pairs belonging to the set the Cartesian product of A and B that are not present in A and C. Since A, we have already proved in the previous problem that the Cartesian product of A and B intersection with the Cartesian product of A and C, that is the null set. This implies, that means if we take the Cartesian product of A and B and from here subtract the Cartesian product of A and C, that is only going to leave us with the Cartesian product of A and B, which means that we now have only the Cartesian product of A and B. What is the Cartesian product of A and B? We have this. We have the set containing the elements 1, 4. We have 2, 4, and then we have the element which is the ordered pair 3, 4. Now clearly both the left hand side and the right hand side are equal. So here we have the left hand side equals to the right hand side. This simply tells us that if we take the Cartesian product of A with the difference of the two sets B and C, this is going to be equals to the Cartesian product of A and B minus the Cartesian product of A and C. The Cartesian product of A and C, hence proved.